Hey guys, how's it going? This is Simon, and this is the second of what will be 4 videos that I'm creating to help you prepare for Test 2 in the Unix security course at Mohawk College. In this video, I'm going to be covering Module 3A, which is all about SELINUX. And that's this guy right here. If you didn't check out the first video, I did cover how to complete Module 3 with you, which was all about secure remote access. In that video, I gave you a bit of an introduction to explain that in these videos, I will go through the entire lab with you. The only thing I won't be able to do is give you any answers to questions that you'll have to submit to your teachers for marks. The other thing I showed you was how to prepare VirtualBox Manager for these labs. And the quick answer is you want to make sure in VirtualBox Manager that the DHCP server option is not enabled. And then you want to go into Task Manager and you want to make sure that there's no task or process called VirtualBox DHCP or VBox DHCP. If you see those, just end the task and you should be good. Finally, you want to make sure that the VirtualBox host-only network adapter is set to the right IP address and subnet mask because we want our host machine to communicate with our virtual machines back and forth. We're definitely going to be doing that in this lab, so make sure you do that and get that prepared as well. If you don't know how to do any of those, check out the first video because I do show you how to do it step by step. But once you're ready, go ahead and load your build server. So the build server that I'm using is from Lab 2. If you don't have your build server from Lab 2, that's okay. As long as you have your build server from Lab 1, that'll be sufficient. As long as you have a build server that's working, that's really all that matters for this lab. So go ahead and get that started, and we'll just wait for it to load. And while we do that, let's click on this link right here that says Lab 03A. So go ahead and log in as root. And let's just go down here and see what we have to do first, and then I'll explain what we're doing in this lab as the new virtual machine that we're going to be creating starts up. So as we can see in the overview, we only have the build server and this new virtual machine that's called W93. The only requirement for this is to make sure the host name is W93 and make sure the IP address is 10.1.1.93. So that's it. We don't even have to make the users Alice and Bob. We don't have to do anything fancy with the firewall. This is a very simple build, so I'm going to show you the simplest way of doing this based on your Kickstart file. So go into the VI editor and edit your Kickstart file, and you can edit the default one. You don't have to create anything new. So we're going to go to /var/www/html/kickstart/default.ks. So go ahead and edit this file. And the only thing that we have to edit in this file is the second line here that starts with network. So what we're going to do is where it says boot proto, we're going to change DHCP to static. Go ahead and leave device as eth0. The host name is going to be W93, and then we're going to put in an IP option. So --IP 10.1.1.93, and then the net mask. So --net mask 255.255.255.0. So if your network line looks like that, you should be good to go. Go ahead and save and quit. Perfect. So now we can build that virtual machine. So let's go into the VirtualBox Manager, click New, type in W93, Linux, Red Hat 64-bit. All the default options are fine. We will go into Settings and make sure your boot order looks like this right here. So if your boot order looks like this, you should be good to go. You can leave your base memory if you want. You can add a processor if you'd like. And then go to network. Make sure it's attached to the host-only network adapter. That's fine. Click on Advanced. Make sure the adapter type is FAST3, and we should be good to go. Go ahead and start that virtual machine up. And we'll just make sure really quickly that it's going to run properly. And then I'm going to talk about what we're going to do in the lab. So I'm going to minimize this for now. We can minimize the build server. Looks good so far. I'm just going to make sure that the initial screen, the gray and blue screen, works, and if I don't get any errors in the beginning of that, I should be good to go. And this looks good. Alright, so let's talk about what we're going to actually do in this lab. So in this lab, we're working with SELINUX, and SELINUX is a mechanism to support security policies in Linux. So as you know from previous courses that you've taken, such as Cisco, you can't just easily implement a security measurement into your server, into your network, and everything works fine. Usually once you do one thing, it impacts several services, and now you're going to have to make sure that those services adapt to that security measurement. And SELINUX is no different. Essentially what we're going to do is we're going to have an Apache web server with a couple web pages, and we're going to enforce SELINUX afterward and show that one of these web pages is not going to work, and we're going to have to configure Apache to work with SELINUX so that it ends up working the way that we want to, and we have SELINUX enforced. So it's kind of a pain in the butt, but you're going to see this lab is actually not too bad to go through. There's not a lot of guesswork, but anything I can do to help, I'd be happy to do with that. Also, one thing that I did mention in the first video that I didn't mention in this video yet is if you do have any questions or you want me to clarify anything I've said or done in this video, leave me a comment and I will get back to you. As long as it has nothing to do with something you're going to get marked for, I don't mind helping you with that. So we're almost done here, which is great. What I'm going to do is scroll down to part A, which says build W93. We've already done the first two steps, which is set the IP address and the host name, and we'll see that once this loads up. The next step is to install Apache, and we want to make sure it's listening on port 80, but the good thing is that's the default configuration, so we actually don't even need to do anything for this. If you want, you can confirm it, but for the most part, you just have to install Apache and it should be good to go. And then once that's good to go, we can create a simple HTML web page, and it's going to be called 1.html, but thankfully you don't have to remember any kind of actual HTML tags or anything like that. We don't have to say doc type equals HTML or anything like that. We're just going to put in words. We're going to make it as simple as possible because that's not really the point of this lab, is your HTML, coding. It's about SELINUX. So let's log in as root. If you want to make sure that everything was working properly, feel free to type in hostname, which will tell you that we have W93 and IP, or let's do ifconfig. And we can see that my IP address is 10.1.93, so everything looks good right there. I'm going to clear this and let's install Apache. So it'll be yum install httpd. So just type this command in, hit enter, and you're going to hit yes twice. So yes once, yes twice, and you are good to go. So go ahead when you're done with that, clear this. But remember, even though it doesn't tell us to do it here, you have to start the service. So make sure you're starting the service. You have to type in service httpd start, and we can see the OK, which is perfect. The other thing that you want to make sure you do is set it so that it is going to boot up every single time. So if we have to restart this virtual machine for any reason, we want to make sure that the service automatically starts. And how we do that is we type in chk config httpd on, and we should be good for that now. So we've just completed this step. Like I said, we don't have to worry about this port 80 because that's the default configuration. The next thing we're going to do is create that HTML page. So use your VI editor and create this page right here, 1.html. Type in whatever you want, doesn't matter, doesn't have to be anything special. I'm going to say Simon is awesome, and I'm going to save it and quit. So if I check that folder now, I should have 1.html. So that's perfect. And I'm in the home directory, so I'm just going to show you that really quickly as well. If I type in ls, I'm going to see that I don't have 1.html here. And the reason why I'm showing you that is because I'm going to download it later. So let's just clear this. And now that we have this HTML page, what we're going to do is put it in a new directory that we're going to create called web. So let's do that. First, let's make web. And then let's copy that 1.html file into web. So there we go. And I'm just going to make sure that we have that in web, and we do. So once you've done that, we've just completed this step. The next step is going to be to make a symbolic link in our Apache web server so that it basically goes to this, this symbolic link will go to this new directory that we created. So we're going to type in ln-s /web, because that's the directory that we want it to go to. And then we're going to create the symbolic link in the Apache web server, and it's just going to be called web. So if you've done that, you should be good to go. Once again, if you just want to check and make sure that everything's working, feel free to. You're going to say ls var www.html, and we can see that we have that there. If you want to see where it's linking to, just in case, feel free to do this, and we can see that this web symbolic link is going to this directory. So everything looks good so far. Let's check our work. We're going to be basically downloading the same web page, but we're going to do it from the Apache web server and from the web directory that we created. So what I'm going to do is clear this, say wget. First one will be the actual server itself, localhost 1.html, and that worked. If I check my home directory, I can see that that file was downloaded. So we'll try the other one, wget localhost/web/1.html, and that worked as well. So if I type ls again, I can now see I have two versions of that file here. So everything worked, and that is what we expected. So let's just remove those files just in case we're going to have to download it later, which we will. Alright, and now we can enable SELINUX. So how we're going to do this is we're going to edit this file right here, which you should be familiar with because we worked on this on lab 3. And all we're going to do is set the SELINUX option to enforcing. Right now it says something like permissive. So let me just go into that file, clear this, use the VI editor to go into etc SELINUX and then config. And yes, SELINUX right here, this is the first option. It says permissive. We're just going to change permissive to enforcing, which says SELINUX security policy will be enforced. So there we go. And you can save that and quit, and then you're going to want to reboot your virtual machine, saying shutdown -r now, and go ahead and just wait for it to do it. So once you've done those two things, we've just completed this and this in part B. So step 1 and 2 in part B, the last thing will be to check that Apache is still working. Now when it says that Apache is still working, it literally means just the Apache directory, not the web directory. So when we do this, it's going to work. We're also going to try to navigate to this web page from our host browser. So this guy right here, I'm going to use Chrome. So go ahead and log in as root. There we go. Let's just make sure that it's still working. wget localhost/1.html, and that worked just fine. So if I type in ls, we can see it downloaded it, so that is good. Let's use Chrome and access that web page. So I'm just gonna copy this, go here, enter, and look at that. Simon is awesome. So it works, everything seems good to go. Seems like there's no problems, but we're going to see that there is. So we're going to move on to part C, which says let's see SELINUX do its thing. So we've already checked and made sure that this works. So this is what's called a safe location, and we saw that it works, but let's try this right here, which is the web directory version of that same HTML file. So I'm going to clear this. We're going to say wget, and this one's going to be localhost/web/1.html. Hit enter, and we get errors. It says forbidden. And we don't really understand why. If you don't really know what's going on, you don't know why, but we should get this. In the lab, that's what you want to see. So it says here, seeing the 403 error, our first instinct is to check file permissions, which makes sense. So let's just check them. So the very first one is going to be ll-l/web. And we can see here the 1.html file has read permissions, so that shouldn't have been a problem. Let's check the actual directory itself, ll-ld web, and we can see the web directory also has read permissions everywhere and execute permissions, so that shouldn't have been a problem either. And that's what it says right here. That can't be the problem because both are world readable. So the next thing we're going to do is we're going to check an error log. So I'm going to do that right here. and just going to say tail /var log httpd, and then error log, and go ahead and hit enter. And there's a lot here, but we can see the last one says error, and it says symbolic link not allowed or link target not accessible, and it gives us our directory web for the Apache web server. So that's the symbolic link right there, and that's what this says right here as well. So he's just basically showing you what you should see, and we do see that, so that is good. So we've completed step 4. Now we're going to move on to step 5. So it says we know a little bit about SELINUX, so we look in var log audit.log for messages with the type of AVC. So let's do that. Let's just clear this, and we are going to say grep AVC in var log audit.log, and we get a bunch of things. So once again, he provides what we should be looking at, which is going to be one of the last things that we see, and it looks like this. There's a lot of stuff that you're probably not going to recognize because it's probably the first time you've seen it. And here we are. We can see this type AVC, and we can see denied, and we can see a bunch of things as well. It's not exactly the same, so when you go here, if you're looking and you see PID 1423, mine's not 1423, mine's 1437. That's okay. Another thing too is you might see something that says right here system_u, but yours might say something like unconfined_u. That's okay. It doesn't have to be exact, but you want to see something that is very similar to this. And if you do, that's great. We can move on to the next step. If you want, you can read this tutorial all about what you're looking at. And he gives you a bit of information, which is kind of cool. So we can see that the COM field is the offending executable. The path is going to be the resource that was denied. The S context is going to show the source context, which basically means who SELINUX thinks is asking. The T context is the target context, which is what SELINUX thinks is being asked for. So don't worry if you don't understand this just yet. We're going to move down to here where it says the power of Z or Z. The command line switch Z adds SELINUX information to many commands. So we're just going to try these. It's not really going to do much, but we're going to try them just to see what they look like. So let's try the very first one. I'll just clear this. ls-l capital Z var www html1.html. And so we get what we normally see, which is your listing information, but then we get this big long line that says unconfined_u, object_r, and all this kind of fun stuff. And this is going to be important down the road. httpd_sys_content_t. But we'll get into that in a second. Let's try the next one, which is looking at our processes. So we're going to say EFL capital Z, and then we're going to grep httpd, and we can see a bunch of things. And once again, we can see this really long line that looks very similar to what we had before, where it talked about unconfined_u, and that's okay. Then the last one is id-z. Make sure it's capital Z, and once again we get something that looks like this, unconfined_u, all that kind of fun stuff. Or yours might say I think it was system_u. Yes, system_u. That's fine. So if you get both of these are good. These are fine. Whichever one you get is fine. We can still move forward with the lab. Alright, so now we can move on to part D, which is make the web directory accessible to HTTPD using chcon. Alright, what we're going to do first is compare why SELINUX accepts the normal Apache directory as opposed to the web. We're going to look at both of those settings, compare them, and see what is different. So that's what this is doing right here. What I'm going to do is just clear this, and let's write this out. So we're going to say ll-capital Z var www html1.html. So that is what is working. This is the Apache directory, and if you go to this, it will work. If we hit enter, we get, again, stuff that is like, okay, cool, but we're not really sure what we're looking at. But we want to compare it to what this looks like for the other directory, which is the web directory. What is different? Why is this working here but not on the web directory? So we're going to once again say ll capital Z, but this time we're going to say /web and the 1.html file. And it definitely looks a lot smaller. So we still have unconfined _u, that's fine. Object _r, well, that's fine. But instead of httpd _sys _content _t, we just have default _t. Everything else is fine, S0 and then the actual file, that's great. So it looks like this guy right here, default _t, is the biggest culprit. It looks like that's different from this, and maybe, just maybe, we should change default _t to this and see if it works. So there's an explanation here. I'll just read this. It says, we can see the only difference between these two files from an SELINUX viewpoint is that they have different types. So that's this guy right here. If we could get web1 HTML to have the same type, httpd _sys _content _t, as var www html 1.html, all would be good. So we have two ways of changing this type. One will survive a relabeling and one will not. Either will survive a reboot. So here is the quick fix. We're going to type in chcon -RV-t, put that httpd _sys content t into this directory. So let's do that right now. Okay, and you can see that it doesn't just change the directory, it changes the actual file in the directory as well. If we had multiple files, it would change everything. So that's really good. It says verify that's working using wget. So let's do that. I'm going to say wget, and what they want is this address, localhost /web /1.html. And that actually worked this time. So if I type in ls in our home directory, we can see that we now have a copy of the 1.html file as well. So let's just remove both of those. And then it says reboot W93. So let's do that. Shut down -R now. And we'll wait for this to go. Once it comes back up, we're going to verify that we can still access that web page. And then we can move on to part E. So we're almost done. So this isn't too bad, and I hope it's not too confusing. I know that this section right here might be a little confusing, but I'm going to talk about this in a second once we're done part F, because I can't give you any answers, and I can't really show you this part because you're going to have to do this on your own, but I am going to give you a little bit of a hint. So now we're going to verify that we can still access that web page. We're going to log in as root. Once again, just type in wget localhost /web /1.html, and all is well. If I type in ls, we can see I have that file here. So I'll just remove it because I'm going to keep on downloading it over and over. But now we are done part D. So let's move on to part E. It says make our type change more permanent. So what we're going to be doing is we're going to restore that directory to what it originally was, which was default _t. So let's do that. Restore con $RV web. Okay, so we can see a little message that says we're going to reset this. So instead of this guy being here, it's now back to its default. And now it says use wget to verify that it's not working. All right, so wget error. So good, everything's back to normal, even though we don't want this, but for the purposes of the lab, we do. Now what we're going to do is work on step 3, which is we're going to use semanage command to modify the targeted policy, but first we need to install semanage. So we're going to install this, which is a really long name, policy core utils -python. Say yes, wait for it to install. This can linger for a couple seconds, and that's normal. And once we've done that, we will move on to step 4, which is modify the targeted policy. And we're going to be typing in this command right here. And what this is going to do is it's going to edit it for this directory and everything in the directory. So this is what all of this is talking about. But if you have any questions, feel free to let me know, and I'd be happy to help. But what we're going to do is, like I said, once this finishes, which it just did, we're going to type in this command. So go ahead and type in SELINUX F context -a-t httpd sys content underscore t, and then in quotes we're going to say /web, and then in brackets we're going to say /dot star or wildcard, and end it like that. We'll wait for a couple seconds. Should be good to go though. There we go. And now we're going to tell SELINUX to restore the context of web and its content to its default value. And unlike what happened here, it will actually put it to the HTTP sys content T, so everything should work the way that we want. So all I'm doing is putting this command in because we're on step 5. Enter, and there we go. It was default because we didn't switch it back yet, but now it's set it back to HTTPD underscore sys underscore content underscore T, so it's back to what it should be. And now this guy right here should work with no problems, and let's just check that out. So I'm just going to put ls in here. I don't have that 1.html file in here, so we're going to try it out, see if we can download it, and it should work. Looks like it did. Perfect. Cat 1.html. Simon is awesome. Look at that. Okay, good job. Let's move on to part F, and this is the last part before you're on your own, but it says allow HTTPD to listen on a non-standard port. So we're going to be putting in this command, SELINUX port-L, and we're going to grep that over to HTTPD and hit enter, and we are going to get nothing. Okay, so what we're going to do is we're going to edit this file, which is our Apache configuration file, and make sure it listens on port 9317 as opposed to 80. So let's go into VI and edit that file. Okay, and just hit enter and go ahead and hit I to insert, and you're gonna have to scroll down until you see listen 80, which is kind of closer to the top middle of the actual file. Just keep going. You'll eventually see something that says listen right here, and you'll know that you're close. So see where it says listen 80? We're just going to change 80 to 9317. So it should look like this, and you're going to save and quit. Okay, and restart the service. So service HTTPD restart, and you might have to do this twice. So okay, try it again, and there we go. We're getting failed messages, and that's what we're supposed to get. It says you should see an error. That's fine. So let's just check out the log file. Like I said, I did this twice just to make sure it goes in the log file. I found that when I did it once, it wasn't as easy to see in the log file. I don't know why, but let's just go into this log file. So I'm just gonna clear this, and cat var log audit.log, enter. So you get tons of stuff, right? But what we're looking for is basically this stuff right here where it says denied, and we can see that we are having issues. So what we have to do is use SEManage to allow HTTPD to access the port that we want, so that way we can have a custom port. We don't have to use 80 if we don't want to. So what we're going to do is type in SEManage port-a-t http underscore port underscore t dash p TCP 9317 and hit enter. It takes a bit, then that's okay. And once this does finish and it comes back to normal, we're just going to start the service again, and I'll do it twice again, You're going to get an error in the beginning, and then it's going to say it started, and then we'll do it once more, and it'll start everything the way that it should normally. So service httpd restart, like this. So that's normal. You got one failed, one okay. If you do it again, you got two okay. So everything should work. And now if we type in wget and we go to that web page, localhost web, or sorry, 9317, that worked. So all I did was type in this command, seemed to work. If I type ls, we can see I have two pages that are 1.html. So everything worked, and this one wasn't too bad. This isn't a terrible lab to go through. The only thing that I will say, because I did mention that I'll give you a bit of a hint, is that you really do need to make sure that you're figuring out what the differences are here. So you see how it said default underscore t, and this had httpd underscore sys underscore content underscore t. Well, when you're putting this through, that is probably not going to be the exact same type that you want. So just make sure when you're going through this, you're not just following these steps to a T. You want to make sure that you're looking for what the actual type should be. Because on BO1, when we're putting everything through, I can tell you that your hint is it will be a different name. But again, if you have any questions about that kind of stuff, go see your teachers. They're always happy to help. I hope that this video clarified anything that you had questions about, besides for the stuff that you're getting marked on. Again, if you have any questions, let me know, and I'd be happy to get back to you. But thanks for watching, and I will see you in video 3.